Okay, now in case of the MANOVA, we are assuming that the categorical variables, they are basically our uh, independent variable. Okay, and the dependent variables are the metric data. For example, I want to find out that is whether teacher training has any effect on the academic performance of the student. Then teacher training, that will be classified into different groups. Maybe some students are trained by the lecture method, some students by project method, some students by the demonstration method. So there are different types of methods are there. And you want to find out whether these methods have any effect on the student's performance. And in that condition, you have to think about what will be your independent variable and what will be your dependent variable. So independent variable has effect on the dependent variable. This is your assumption. Okay.
Yes, sir.
Now the challenge is there are different situations where in your independent variables, they are the metric data and your dependent variable is the categorical data. Just opposite. Okay. For example, you want to find out that is the safe school perception. So when the students, they perceive that the school is safe for them, whether their attendance motivation is high or low. Okay.
Hmm.
I did that type of research. And based upon the safe school perception data, I could predict that is what is the probability for the student to continue the class, to attend the class, or not to attend the class. This is the concept of machine learning also. Because in case of the machine learning, you are giving training to the computer that this is the data. You ask the students, and if you find that is the students discriminant function is this, then you can predict that there will be the high absenteeism among the students. Like that, you can ask some questions to the patient, and based upon your questions, you can classify the patient into specific psychiatric categories. Okay. And when you can do this, when there are many variables, the independent variables, and they are related with each other. Therefore, you have to partial out the effect of the variable. For that reason, you have to do the discriminant function analysis. That means several factors are there, and those factors are related with each other. And you have to find out which factors are relatively strong contributor for predicting the change in the dependent variable. Okay.
Yes, sir. Just as scoring the number in mathematics, whether there may be the factors like that practice, then memory, then the concentration. So these type of factors, so which is going to effect most effectively, so that we have to find it out. Is it?
Yeah, almost
Okay, sir.
similar.
Okay.
Now, discriminant function analysis is widely used in medical diagnosis, not only in educational field, but also in medical diagnosis. Discriminant function is used highly in case of the microbiology, genetics. Okay, not only in psychology, but also in other fields for predicting what is your predictive capacity. Now, in one of my research, I have used the discriminant function, and I could predict more than I think 85% correct classification to predict whether the NCRT data is correct or not based upon my data. That means I collected the data from the schools about their infrastructure. And I collected data from the NCRT that is available in the net. And then I classified NCRT data, the schools, basically the schools, into two categories. That is the high performing and the low performing. High and low performing, these two types of data. And I have used discriminant function analysis there. And by using the discriminant function analysis, I could predict whether my data is correct for predicting the NCRT classification or not. So therefore, you can use the discriminant function for the educational purpose. And here I like to share that discriminant function analysis is used by the AI through the machine learning process. Discriminant function that is used. For example, when you download Zepto, Swiggy, Uber, Ola, Zomato, they are getting information about your mobile. Okay. And getting that information, the companies are able to find out your socioeconomic status. Understand my point?
Yes, sir. Since whenever we are going to fill up any form, na, already they provide the email ID, what is the address, what is the age, what is the educational qualification. Already they ask me, do you want to do the autofill, or sometimes they do by themselves.
Correct. So this is a huge data. And based upon that, they will tell you that is whether the Uber charge or the Ola charge will be this or this. If you are in high economic status, you will not uh, go for the mini car. You may go for the uh,
Prime sedan or the
correct. So they will give you that type of car first.
Just today it has happened, sir. When I booked the car from
Hmm.
Malik Bazar Neuroscience to my place, my
Hmm.
home, so that is they were asking for that 550. But when my brother, who is admitted there, so he willingly was trying to find it out. So in his mobile, the same app, it has showed that that is the 260 rupees only. So I told my brother that you book it, and since it is the cash payment, so that will be helpful for us. Just today. Since I
now you
use
can now you
Rapido
can
to,
relate
yeah,
it.
yes, yes. Sometimes that is when you are searching frequently, they will ask the more. And so that is the thing also.
That means they are getting all the information about you, and they are calculating the what is the probability.
Yes, it is. I have observed it. Regularity means hike the price. And sometimes, so that's why I have downloaded 4 or 5 apps, just like Uber, Ola, Rapido, Moto, Jatri Shati. So when I compare and then I try to. Sometimes if I don't use the suppose Jatri Shati not 1 week or 2 weeks, so when next I am going to book it, so it will show me that lower price.
So this is their policy.
Yes, that is already I have observed.
So they are getting this information from your own mobile. Okay.
And not only that, also, sir, if you go for the Facebook or anywhere, na, so that is what kind of thing do you like, na? They will show the advertisement like according to your choice. They will show frequently. Are you interested? Are you interested? Or that those type of informations they will provide in the YouTube also. The similar product or similar type of things that will come.
So now you are able. So maybe one individual has some problem in the uterus, and all the based upon some of the diagnostic parameters, computer can predict that this is the location where the problem lies. Okay. So now, so this is the machine learning, and based upon that, AI can tell you a lot of the information. That is, this person has this type of problem, so you do this type of treatment. Now you will find that is there are some AIs, they are called the generative AI. That means this AI can give you the suggestion also. But be careful, whatever the information AI has, based upon that AI give you suggestion. AI has also the limit, so you have to be very much careful. You must be very much educated about the concept. Now it is clear to you.
Yes, sir.
Now you go to the Google Classroom.
Yes, sir.
And go to the,
Discriminant function analysis.
yeah,
We read now.
please read it.
Discriminant function analysis DFA is a statistical technique used to classify observations into predefined categories or groups based on one or more predictor variables. It is a supervised learning method that aims to find a linear combination of features that can separate two or more groups. Key concepts: discriminant functions. These are the linear combinations of predictor variables that are used to classify observations. Number two, classification. The process of assigning observations for predefined groups based on the discriminant functions. Number three, predictor variables. The variables used to create the discriminant functions. Application of DFA: marketing and customer segmentation. DFA can be used to classify customers into different segments based on demographic, behavioral, and transactional data. Medical diagnosis. DFA can be used to classify patterns into different disease categories based on symptoms, test results, and medical history. Credit risk assessment. DFA can be used to classify loan applicants into different risk categories based on credit score, income, and other functional data. Quality control. DFA can be used to classify products into different quality categories based on manufacturing data and quality metrics. Social sciences. DFA can be used to classify individuals into different social or psychological categories based on survey data and behavioral metrics. Steps involved in DFA: data collection. Collect data on the predicted variables and the group membership of each observation. Number two, data preparation. Prepare the data by checking for missing values, outliers, and multicollinearity. Number three, discriminant function estimation. Estimate the discriminant functions using a statistical software package. Classification. Use the discriminant functions to classify new observations into the predefined groups. Evaluation. Evaluate the performance of the DFA model using metrics such as accuracy, precision, and recall. Advantage of DFA: improved classification accuracy. DFA can improve classification accuracy by identifying the most important predictor variables. Reduced discriminality. DFA can reduce the dimensionality. Oh, sorry, reduced dimensionality. DFA can reduce the dimensionality of the data by combining multiple predictor variables into a single discriminant function. Number three, easy interpretation. DFA results are easy to interpret as the discriminant functions provide a clear understanding of the relationships between the predictor variables and the group membership. Limitations of DFA: assumes linearity. DFA assumes a linear relationship between the predictor variables and the group members. Number two, sensitive to outliers. DFA can be sensitive to outliers, which can affect the accuracy of the classification. Number three, requires normality. DFA assumes that the predictor variables are normally distributed, which may not always be the case. Then to our script, sir.
Okay. No, our script is not required.
Yes.
You can limit up to this one. Now, I think whatever the texts are there, you have understood. Or if you have not understood, you can ask me. Whether you have understood the collinearity.
Yes, sir.
Okay. You have understood the
Though I have understood, sir, collinearity when you have told, so just once you cite one example.
yeah, because in research, sometimes we find some of the variables, they are correlated with each other, maybe more than 0.9. Okay. That means the two variables, they are measuring the same thing, but in different names. Okay. In that condition, you have to find out, that is whether your measurement tool is correct or is valid for the classification of that particular trait or not. So in that condition, the DFA can provide you this information that your tool has some measurement error. Okay, therefore it is not able to predict the correct classification. For example, I want to find out, that is, what is your probability to be the teacher or to be the engineer. The engineering occupation has something about the teaching, and teaching involves some technology adaptation. So therefore, the task are some tasks are related with each other in both uh, engineering as well as the teaching. Okay. And based upon your task preference, if I want to predict whether you will take the engineering job or the teaching job, I may not be able to give the correct classification. Okay. So I have to consider some other variables also instead of only the task preference. Now it is clear?
Yes, sir. I was thinking about the poll vote.
Uh, that is also true. Vote. Sometimes we are thinking that this individual will be able to provide some of the services. Based upon that, we are casting the vote to that individual.
Hmm.
But after the election, we are not getting the support. That possibility also there. Therefore, discriminant function is very powerful statistical tool and highly used in machine learning. Now, it is clear.
Yes, sir.
Another thing is the reduced dimensionality. Now, when we find that is my independent variables are more, then it becomes very difficult for us for predicting the predicted variable. Why? Because the independent variables, they are also related with each other. Okay. So we have to partial out the variance from each independent variable. That is also important. Therefore, when there are more number of variables and the variables they are related with each other, then we can use this dimension reduction through the uh, DFA. In case of the ChatGPT, you may find that is the ChatGPT is providing you two types of messages. Have you received?
What kind of, sir? Chat GPT?
Yeah, you have asked some question to
Yes,
ChatGPT,
yes, 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 yes.
and
I use it.
ChatGPT is giving you two kinds of messages. Or in the Facebook, if you have the Meta, uh, whether you are getting Meta nowadays?
Yes, sir. Meta, Gemini. Yes.
No, in Facebook.
Facebook, Meta. They ask for that AI support or not. Yes.
Achha, but I am not getting the Meta. I do not know why. AI
Sir,
support earlier I received.
going to give that that is the reel or the that kind of thing, na? So that is they will ask the AI something like this.
Oh, so if I prefer Instagram, thread, reel,
Yes,
then
sometimes they will ask the preference. Yes.
then they will give the meta service.
Yes.
Okay, okay, because I have off all of them. They are disturbing, so I am not received meta. Okay, now I understand. And whether meta is charging some money now?
Yes, sir. Sometimes that Facebook they will ask that a subscription that thing.
Acha. Okay. So now you can find out in case of the meta also, they are providing different type of images to you, and they are asking you that is which image you prefer. Okay. And based upon that, they are able to reduce the dimensionality. Is it clear now?
Huh, sir.
Now I am requesting Farah to share the screen for the art script.
Okay, sir.
So this is the art script Farah is presenting. You have to install two packages. One is the psych, another one is the mass. So you have to install these two packages. After installing, you have to call the install package by writing library command. Okay. And then the computer will read your data. So Farah, please from 17 to 21, not the full data. Acha, acha, okay, you can do the full data and then we can go. Since it is already installed. Okay, now uh, one sec. What are the vectors created? First one, please you show the iris data.
Yes, sir.
Now you write down iris, or only iris.
Yes.
In this, not in this manner. You have to write down head iris,
Okay.
head iris, comma 1. Okay, that means this is the first row. In this manner, all the data are there. First row includes the sepal length, sepal width, petal width, and the species is Setosa. Now, you have to be very much clear about the nature of DFA. DFA follows supervised learning. Why supervised? Because you know from previous research that This particular measurements are related to this particular group. For example, the sepal length, sepal width, petal width, whatever the things are there, the parameters are there. So that indicates it is setosa. Okay. Shoma, it is clear now.
Yes, sir.
So now
What
you
kind
write
of
down,
species, sir? What kind of species?
it is the flower.
Okay,
Okay.
okay,
The flower name is setosa.
acha,
Iris is one kind of flower,
okay,
and these are the parameters. 4 metric parameters, and one is the non-metric parameter. That is the setosa. Okay.
okay, sir.
Now you write down head, iris, head, iris. No, no, not no comma. So here you can find out that is the pattern of the data. Now enter. Okay. That means initially data are setosa in nature. So this is the original data. Okay. And
Okay,
it
sir.
is the previous assumption. That is, this flower is setosa flower.
Yes, that
Okay.
assumption has merged.
Yeah,
Yeah.
already there.
Hmm.
Now you write down names, bracket IDs, dollar, species. Enter. Okay, sorry, you write down table. Uh, so here you can find out 3 groups are there. One is the setosa, another one is the
The versicolor.
versicolor, another one is Virginia. So 3 types of iris flower are there. Okay. Shoma, it is clear to you. 3 types of flowers are there. And
Okay,
these flowers are already known. That is, it will be setosa or versicolor or the Virginia. And how many flowers are there in Virginia? For each group, 50 flowers are there. And now you have the data. So this is your data or parameter. That is the sepal length, sepal width, petal length, and petal width. So only the length and width uh, you are supposed to predict whether it is Virginica, versicolor, or setosa. Okay. For that reason, you have used the DFA. And Farah, now you write down the table. So now you go to this script. Last line. Irish species, yes, only this one. Now you have noted that is no other data. So here you can find out that is whatever you have collected the data, based upon that you are able to correctly predict setosa. So it is 10% correct. And your misclassification for the versicolor is only 2, na? 2. Misclassification is there. That means 2 flowers are there. They are seem to be versicolor as well as the virginica. Another thing, the same it happens in case of the next color, virginica, next type of flower. Okay, and there you have also seen so 49 is the correct classification. So correct classification is 49 for the virginica. Correct classification is 48 for the versicolor. And in case of the setosa, you are able to classify setosa in proper way. That is the correct classification. Now, Farah, you go to the script. Yeah, you write down this thing. Yeah, you write down summary iris DFA. Summary iris DFA. Okay, not summary. You write down iris DFA. So this is the result. So two broad classifications are there. One is the LD1, another one is the LD2. That means one will be the correct one, another will be the incorrect. For example, for LD1, you will find that is the correct is the sepal length and sepal width. No, sorry. Correct one is the sepal length. And sepal width is the 2.16. So LD2 category 2.16. And what is the proportion of trace? 99%. So 99% correction is there. That means your DFA is able to classify the flowers into 3 categories with very much correct classification. Now, in this type of test, you have to divide your data into two categories. One is the training data, another one is the test data. So total, how many data are there? How do you write down DIM? Irish. Enter. Yeah. So you will find that is the 150 data. Total is the 150 data. That means
three types, so three types means 3 into 50 in such a way.
It is the 150 data are there total. Okay. And three columns are there. No, sorry. How many columns are there? 5. 5 columns are there. Okay. And this 150 observations, 150 multiplied by 5, that will be your total observations. But here you can think about the 150 into 4, because this is your data. And the other data, that is the fifth column, that includes the species data that is already determined. Okay. Now, when you want to train the data, then you have to classify the data into two categories. More will be in the training data and less will be the test data. So you may think that is the 75% data you will choose randomly from this 150 total data, and you will apply your DFA model, and based upon the model, again, you are testing the test data so that you can tell that is my model is correct for the classification. Is it clear now?
Yes, sir.
So this part is important. When you want to apply your model, before that, you have to apply DFA model on the large database. And if you think that is okay, it is correct classification is there, then you can test it on the small data. Because already you have the data. Now, Farah, you go to above. It is written now, predict irish.dfa irish. Yeah, this one. Now, this is the prediction. So this is the prediction. Okay. That means in case of the setosa, prediction is correct. But in case of the versicolor, there is misclassification, as well as in the Virginica, misclassification is there. So you have to find out which flower has the misclassification. From here, you can find out that is which flower is misclassified. For example, you know that is in case of the Setosa, 10% correct classification is there. But in versicolor and virginica, the classification, not the 10% classification is there. So based upon these parameters, you have to find out which flower has the misclassification.
Such as here, number 27 maybe, 24 maybe in the versicolor. Highly, that is high one, 8.91, 3.96. Is it like this? How do I? Such as in the Virginica, number 24 maybe. Like this, sir.
Is there any minus sign?
In the 24, for the Virginica, we are getting 9.17862 E minus 32.
It is not the minus, it is the exponential.
Exponential 32.
And that maybe that is the indicator.
No value is negative value, sir. No minus sign is here.
No, it is a 150 data is there. You go below.
Okay, okay.
You go below, Farah. Is there any one? This is the LD1 and LD2. Setosa high. LD2 is less. Next one also 7.12 and this is 0.78. You are telling 24, no?
Yes, I was predicting that 24 maybe. No,
No,
here the
24.
25 negative, 26 negative. Such as 8 negative for LD2.
Okay, Farah, is there any histogram? Just you check. What is your vector name, Farah? Predict, no?
Yes, sir, predict.
No, you have not made the vector.
So what?
It is the function.
Yeah, it is a function. So
If you can make the vector name, then possibly you will be able to find out. ID's data played.
yes, sir. Now.
Now you write down whatever the things are there. Predict something.
Okay, so 1 second.
Enter. Now you write down attributes, bracket, ID's data, predict. What you have written. That is the class posterior and the X. So you write down hist, bracket, iris data, bread dollar X then enter. It is -10, it is a +10. Frequency, that is also there, no? Correct frequency. Okay, instead of the hist, you write down plot. You go below, write down plot. Then what is the thing? Where is data rate X? One data is there, less than 2. In case of the LD1, LD2 less than 2, as well as LD1 less than 0. Which data we have to find out. Okay, Shoma, maybe this is the data
Yes, sir.
that
Yes,
causes the
sir. Totally scattered.
yeah. So this is, in this way you can find out the misclassification. Okay. So this is all about the DFA. So please you study the note thoroughly. And if you apply the R script, what is written there, you will be able to understand more. So this is clear, Shoma?
Yes, sir. Clear.
So what are the predicting variables and what is the relative weightage for predicting the change in the predicted variable? That could be understood through this DFA, discriminant function analysis. Possibly this is the last theoretical class, no? Farah?
Yes, sir. This is the last lecture on last chapter, sir. Last paper.
Last chapter. I think there
Yes,
is no other chapter is there.
yes, sir.
So I have completed the multivariate modeling for the categorical data analysis in this manner. And I am requesting you all to attend Sunday webinar that will be on the machine learning, introduction to machine learning. And there I will show you some of the data. So through the data visualization, you can get some idea. Okay. So
Yes, sir.
now I want to close the session for our next session.
Sunday, which time, sir? What time?
Sunday 10 to 11
Okay.
morning.
Yes, sir.